The first thing you're going to do is put the number of absences X in L1 and the final exam score Y in L2. Make sure the values line up. The 0 goes with the 89.1, the 1 goes with the 87.1, etc. So take a moment and put those in L1 and L2 in your graphing calculator. Type it carefully and double check each time as you go along to make sure your values are exactly what you want them to be. Then you're going to go to Stat. So Stat. Then you're going to go to Calculate. And you're going to choose option 8 or 4. I like option 4 better. So Stat, over to Calculate, down to option 4. It says Linear Regression. Your X list should be L1. If you need to change that, you're going to push second. And then the number 1 for L1. And then your Y list should be L2. And you'll push second. And then the number 2 to get L2. And then the next option says frequency list. Make sure that doesn't have anything in there. So just hit clear or delete. Make sure nothing's in that blank. And then it says store regression equation. And you don't want anything in there either. It should be nice and clear. Nothing should be in there. And you'll just go down to calculate after that. So we're going to put L1 for X list, L2 for Y list, no frequency list. Don't need to store the regression equation. Just go down to calculate. And then it should give you the answer for part A. So if we go up to part A, find the least squares regression line. From your calculator, you should see that A equals negative 2.83, and then just repeats 18, 18, 18. So that's why it rounds to negative 2.38. So A is your slope, B is your y-intercept. It says that B equals 88.76, and then it says 18, 18, 18. So that would round to 2 if we're rounding to 3 decimal places. So that's where those values come from. Part B says to interpret the slope and y-intercept. So for every additional absence, the student's final exam score drops by the slope of the regression equation. We're used to calling that M. Your calculator calls that A, the coefficient in front of X. And the average final exam score of a student who misses no classes, so when X equals 0, that would be your Y value. That is your y-intercept. Sorry, new pen here. That's your y-intercept. And so both of those are appropriate values. Your y-intercept does make sense. It is possible to miss no classes. Part C says predict the final exam score for a student who misses 5 class periods. So X equals 5. We're going to take that 5 and we're going to plug it into what we call y hat, our predicted y value. So we're going to take negative 2.838. We're going to multiply that by 5. And then we're going to add 88.762. So all we're doing is taking that 5 and we're plugging it into the equation we got in part A. So that gives us what we call y hat, our predicted y value. So let's do that. Negative 2.838 times 5 plus 88.762. If you type all that in correctly, I got 74.9. point. Oh, sorry. I don't know what I just did there. 74 point. Oh, keeps doing that. 5, 7. Oh, sorry. 74.572, which is what that y value is. That's your predicted y value. Then it wants you to compute the residual. The residual is the difference between, sorry, that's not y. Let me erase here. Okay, so the residual you can see this on your formula chart. It's the actual value minus the predicted value. So the actual value comes from the table of values that we originally put in the calculator. So you can go back to Stat Edit and look up 5. We saw, when x equals 5 on the chart, it said that y equaled 73.6. That's our actual from our actual table of values. The predicted value we got is the one up here, 74.572. So we're going to do actual 73.6 minus the predicted value 74.572. And we're going to get a negative residual because the actual is less than the predicted. So we're going to get negative 0.972. And that's where that value comes from. Whoops. It's below average because it's negative. And then if we keep going, finding the least squares regression line on our scatter plot. It's not connect the dots, so it's not D. It's not a flat line B. It's not going to look like that. It's a line of best fit that goes through the values. And if you wanted to be sure, you could type it on the calculator, but really you can just eyeball where that line of best fit should go. And then part E, would it be reasonable to use the least squares regression line to predict the final exam score for a student who missed, it says 15 class periods. Sorry, 15. So we have to look at our table of values. In our table of values, the highest number we have is 9 absences. So 15 is outside of our scope, which is option B. The x value 15 is outside of our domain, which goes from 0 to 9. So we can't make a prediction outside of our domain. And that is it.